Okay, thank you. So for today, we've got a special treat. We've got Scott Alberts from our very own statistics department.
That's it. That's me.
He's going to talk to you about stuff.
I am. All right. So, how's it going? Yeah, that's all right. Only a couple weeks left.
High level crowd at 9:30.
Well, that's all right. We're gonna get through this, right? 2 more weeks. That's it. So I'm Scott Alberts. I teach statistics just down the hall. And my background is in survey statistics and optimization. So my undergraduate degree is in math. So in that sense, I am kind of like you. My graduate degree is not actually in statistics. So if you were hoping to see a real statistician, you still have not. My degree is in industrial engineering, which means that I look at how industrial processes and how people and systems work to make decisions. And that's a very mathematical area, but it is quite separate from mathematics. So today I'm here just to talk. I'll probably take half the time, depending on how long you want to talk. It looks like you're real chatty. I'll talk for probably half the time just about some choices that you have in the time you have left here at Truman as you think about careers, grad school, all those sorts of things. So most of you have already had Stat 290. If not, you should. It's a cool class. If you had Stat 190, there's the whole way to work around. The main difference between Stat 290 and Stat 190 isn't the statistics in it, it's the math in it. So if you remember Stat 290 where you did the area under a curve and you called that an integral, imagine if you didn't know calculus, and that takes like 3 weeks to do. But for you guys, we just go, it's an integral, and then you're done. So we can cover more stuff. But in terms of the actual statistical content, you actually have, all that you need to have kind of that basic understanding of how statistics works. That idea of inference, the idea of how weird is weird enough that we start to think that our assumptions aren't right. We would never call it a proof, and certainly people like Dr. Ryan would correct me if I said, but in a way, we're doing a proof by contradiction, except it's not a mathematical proof, it's an inductive database proof, right? You start with an assumption and you say, gosh, if we keep going down this path, we get to a place that's so ludicrous that we start to reject the assumption that we started with. And that's a lot of what statistics is. So it's not even so much that we search for correct answers, it's that we try to get rid of all the wrong answers, and everything that's left sounds pretty okay to us. And of course, we've been in the news a lot lately between vaccines for COVID and here there was an election last week. I don't know, you may have heard. That idea of what is unreasonable. And that's where things start to come along right now. We're thinking about vaccines entering their phase 3, coming out of their phase 3 trials. So we've already shown that they're not poison. That's phase 1 trials. We've already shown that it works some against the vaccine, against the disease. That's phase 2 trials. Phase 3 is where you give it to a ton of people. You look for side effects, you look for dosages, and you look for efficacy among different subgroups. Okay, you don't need probably to think very hard to think about how the math of that would work. The idea that, oh, when you give it to older people, it works better, or it works better in women than men, or whatever. There are actually 12 vaccines under consideration right now for COVID, and it looks like some of them are going to have different answers to those questions, right? You'd like to think there's 12 vaccines being tested. These 3 suck for whatever reason. Either they have side effects or they don't work as well as we thought in the smaller trial, or these 3 are awesome, or this one works, but it's really expensive. Certainly those kind of things we do. But this idea that we gave each of the test vaccines to about 20,000 people means that we can actually go down in deeper to see how does it work in children, how does it work in seniors, how does it work in men and women? Are there ethnic differences? You'd like to say, gosh, medicine shouldn't work differently. And I would agree, they shouldn't, but they seem to sometimes. So even that idea that while we're doing our trials here, St. Louis is one of the centers of one of the trials. Because it's a mixed vaccine trial, they're actually not just testing the vaccine that was developed in St. Louis, but they're testing all of them. And that gets you a nice mix of people. You can also see how the COVID spikes move differently in different parts of the country or parts of the world. The Pfizer one that was announced earlier this week is from Germany. It was tested in Germany, Brazil, and I want to say Tanzania, but I don't know. Your Google is as good as mine if you really cared about that. But the idea that just doing it at different sites and different locations will give you different kinds of data that you can dig into. All right, so you guys are math majors, presumably. If not, you're in a weird class. Maybe this is a cool elective for French majors. But the idea, though, is that you can certainly have a career in statistics, a career in statistical-driven stuff. And it might be that you would want to take 1 or 2 more courses in the time you have left. I know some of you are graduating relatively soon, and others of you have a few semesters. So that's really what I want to talk about for most of this. So traditional graduate school in statistics is actually very mathy. And so up until about 10 years ago, there were more people got a PhD in statistics with an undergraduate degree in math than an undergraduate degree in stats. Of course, Truman didn't have an undergraduate degree in stats until 5 years ago, so we're part of that. If you'd like to go to grad school in traditional statistics, Stat 570, Stat 571 are really the only choices that you would have to make. They want you to have had matrix algebra, they would have wanted you to have some, certainly the calculus sequence and those sorts of things, but most statistics grad programs really don't want you to have that much in the realm of statistics. If you have one more class beyond that, 570, 571, you would probably take one of our 300 level applied classes. That would be 330, which is linear models, or 375, which is ANOVA, or 378, which is regression. And any of those classes would give you that kind of basic background in doing statistics with real data that would prepare you for that. Some of you already know about the actuarial science minor. That's certainly a career that a lot of stat majors go into. It's, again, a mix of math and stat along with some business applications. It looks at insurance statistics, which when I say it like that sounds really boring. And maybe if you go deeper into it, it'll still sound really boring to you. But it's actually a pretty interesting problem, this idea of risk. How likely is someone to have something happen to them, good or bad? We tend to think of actuaries in the traditional form, which is a very structured career. If you're interested in that, beanactuary.com is the website that gives you all the information about that. It was supposed to be smooth. There we go. Beanactuary.org has all the information about it. What's great about the actuarial career is that it's one of the most meritocratic fields that there are. You get a raise by passing a test. There's nationally administered tests where you sit down and you study and you give your answers. And if you do well, you get a $10,000 or $15,000 raise, right? That's kind of cool. I'm a professor. That doesn't happen to me. And when I do get promoted, there's a very complicated process that has a lot of steps to it. And the actuarial firm, it really is, what skills do you have? How have you demonstrated them? And so you guys, lots of you know Steve Smith in math, who is our main actuarial guy. Math 330 is the class that we teach for that. Along with Stat 570, 571, you would be ready to pass 2 exams and go into a career as an actuary. There are a couple of insurance-related jobs that aren't quite the same as actuaries, but use a lot of the same skills. Underwriting is one of those. Underwriting is the idea of how you price insurance. So an actuary makes big models, and an underwriter gives person a policy for a certain amount of money. Okay, so I needed insurance. I'm a statistical consultant, so I do outside projects sometimes. And the project that I'm working on, they wanted me to have insurance. And I said, sure, whatever. And I asked them specifically what they wanted, and they wanted me to have $1 million in liability, right? So if somebody sues them or me, they would be able to pay out $1 million in a lawsuit. Now, I'm doing surveys and stuff for them, so I'm pretty sure that I'm not going to get sued. And if I am, I've seen how, I work for the state of Missouri. They're not going to get a ton of money out of me, but I looked to see how much it was. And for 3 years to get $1 million worth of insurance for like that, less than $100, right? And that's because it's really, really, really unlikely that they're going to have to pay that out. So it's this form of assurance to them. Then assurance, which is the word I just used, is another thing, which is where you do backup insurance. So that is a little bit different than regular insurance, where you do things where, for instance, bonding for employees. So for instance, plumbers, they have insurance, which is a little bit different than regular insurance. that kind of backs up the regular insurance in case something catastrophic happens. So behind the $1 million policy in case, they burn a house down or something. All of those jobs, of course, use math and stats, and the actuary track gets you set up for jobs at those. The Midwest is sort of a headquarters for insurance. Omaha, but also Kansas City, St. Louis, Columbia, Chicago, all have pretty big insurance companies housed there. So if you like the Midwest, it's hard to go wrong with actuary as a career path. Right, so the next job I wanted to mention is the idea of data science and big data analytics. And of course, that's certainly a buzzword. You hear people talking about it all the time. Predictive analytics. Predictive analytics is really a mix of math and stat, but also ideas from business and then coding. And I know most of you guys have had CS 170 or 180, so you've had a first coding class. Certainly, if you're thinking about an elective in your last year, taking one more coding class is probably not going to be a bad decision. You could also take one of our data science courses, which specifically look at how that sort of thing works. Stat 250 is statistical computing, and that teaches you how to do traditional statistics in R, coding language. That runs next semester. Stat 220, which is our introduction to data science course. If you've had CS 170, you'll probably find that a pretty easy class because it is meant for business majors who haven't had CS 170 or 180. So it starts with kind of the basics of coding, but then gets into these big data models. We do look at some pretty gigantic models. If you think about, doing simple math a lot, that's a lot of what predictive analytics does. And so we look at those models. Stat 220 is taught every semester. It's taught in the summer. Again, it's a pretty mellow class for you all to do. So Stat 220, 250, and then CS 170 would make you prepared for a job at an entry level as a big data analyst. We certainly do have some higher courses, including Stat 320, which is all about visualization, making cool charts, and Stat 420, which is multivariate statistics and data mining. And that is really looking at the mathematics of how all of it works. That class has a matrix or linear algebra prereq because we do matrix stuff. If we have time, I'm going to come back around and just show you a really kind of a simple problem that exactly scales up to make a big, gigantic problem. If you're looking to just do statistics, most of those positions are listed as analysts in the job search process. And for that, any of our 300 level classes would probably prepare you for that. So 375, 378, or 330. What I think you'd find surprising about most people who do statistics at a company is that they don't use fancy software. They typically use spreadsheets. And if you love making giant if-then things with 7 parentheses, man, is there a job for you. We in statistics tend to make fun of that, but it's literally what makes corporate America function, are these big giant spreadsheets that do stuff like that. A couple of other specialty careers, quality statistics works for factories. And you could imagine sort of in a very simple sense, over time, a machine starts to get out of calibration and you have to fix it. And so the question is, how far out of calibration should you let a machine get before you stop the whole assembly line and fix what's going on? There are jobs doing this most everywhere. A single stat course beyond Stat 290 would probably be all you need to take that. We do have a quality control class, Stat 374. The Kraft Heinz plant up north of town, they have 3 people who that's their job. And you'd say, well, gosh, they just make pork. And of course they do, right? They take pork from the slaughterhouse and they turn it into products. They put it into packages and boxes and ship it out. But the packages have to have the right amount of stuff. They need to have the right thing. They need to check for safety as well. So again, kind of simple statistics done a lot. How much pork is made at the plant north of Kirksville? 400 semis a day, right? So a lot, right? So as you're thinking about, well, gosh, aren't you doing the same math problem all the time? Yes, but if you do it wrong, then the machine breaks, it goes down, or people get sick. And of course, pork is the thing that people extra worry about getting sick from eating. So that job is actually really important. Optimization. So I mentioned I work in systems engineering or industrial engineering, and that's a whole field. Informs.org is the site that does that. Informs is a group that talks about operations research and analytics, and Math 400 is a course that's taught somewhat regularly. It's not that often, but Dave Garth taught it last year. So he'll probably be teaching it again sometime in the future. I used to like to teach it back when we were a combined department. I miss teaching it. But that's one where you really look at how you work within a system of equations. So instead of imagining you're solving a single math problem, imagine you're trying to solve 10 or 12 at once. And while, in algebra class, you do that with linear equations, now you start to make it more complicated. Maybe some of them aren't linear. Some are strict constraints, meaning that as long as you're past a line, it doesn't matter where you are, where others are goals. So the more you do, the better. So if you imagine a very simple problem is you're going to go to McDonald's and you want to meet all of your nutritional value for the day, but you want to spend as little money as possible to do that. So we can make linear equations of, well, how much sodium is the most you should have? How many calories, how much vitamin A, how much calcium, how much whatever. The problem at McDonald's is sodium, by the way, because everything's really salty there. You might add other constraints like, I don't want 10 of the same thing, right? If they told you go and order 8 salads at McDonald's, you would say that's not actually a feasible answer because going to McDonald's for salads is stupid. But then within that, you just say, I want to minimize cost, right? And you know how to do that, right? You just take the derivative and set it equal to 0, except that you have to do all 70 of those equations at the same time. And so again, it's a linear algebra problem, but it has all of these extra complications added in. Again, my program, I went to Northwestern for grad school, which is pretty okay school. All they want for graduate school is the calc sequence, matrix algebra, and then 1 upper math course, and then 2 statistics courses. So if you took Stat 290 and 1 more, you would be ready to go to the program that I went to do that. All right. The American Statistics Association is the group, the national group that thinks about statistics. It's one of the oldest professional societies in the United States. It's actually older than the American Mathematical Association, which we like to point out, because it was founded by people doing statistics. It wasn't founded by professors who were studying things. It was founded by people in different areas who realized that the solutions they were looking for were coming from different places. So it was founded by agriculture people. Florence Nightingale was one of the founding members from nursing. But there was nobody from Princeton or Yale or Harvard as part of that founding group, because in fact, back then they thought statistics was kind of lame because it wasn't real mathematics. You've met those people. But this idea that for 180 years now, we've been trying to solve these problems. Related to that, the idea that the best programs in statistics are typically not the ones at the fanciest universities. So if you think, oh, I love statistics, I want to go to Harvard, that's actually not a very good choice. I know, Harvard's fine for anything. You'll be fine if you go to Harvard for anything. But the best programs in the United States are Iowa, Iowa State, North Carolina, Michigan, Ohio State, Georgia Tech, ones around here. Some of that was because of the agriculture focus. Statistics at Iowa State was actually housed in the agriculture school until about 20 years ago. North Carolina has a big program. They were founded by tobacco companies to try to show that smoking did not cause cancer. That didn't work out so well for them, but they still have this gigantic statistics program as a result. So there's lots of opportunities for that. Most programs are actually really looking for American students to go to grad school in those areas. Right now, many of the programs are dominated by international students, and while international students are great, many of the schools have contracts or grants from the federal government that can only use to fund American citizens. So it's actually sort of a funny thing that you would think, oh, they really want me to have a 36 ACT and a perfect score in the GRE and whatever. And while they want you to be really smart, it's actually sort of an unfair competitive field because they do have this extra funding. That said, in most cases, if you go to grad school in statistics or statistics area, you won't pay to go to grad school with a few exceptions. Many master's programs will not promise you money at the beginning, but instead they'll have TA-ships that you can get in your first year, which will give you funding. Our friends at Illinois, which is another pretty good program, they have a business incubator there. So what they do is that they don't give you a fellowship in the formal way like other schools do, but instead they give you an internship. So you typically work for a company 15 or 20 hours a week while you're going to school. Some people choose to pay for your first year at Illinois, and then after that, you get fully funded. But others take even a part-time job that first year so that they can do that. The program in Illinois is, there's actually a lot of Truman people there, over there in Champaign. So they're doing a lot of stuff. But the business incubator they have there has over 150 companies. And what sort of their specialty is that companies that are based in Chicago, they want them to move their research office down to Champaign, where of course it's cheaper, rent is cheap and all that kind of stuff. But then you can get all the college students from different areas to work for them. So like I said, they have 150 things. The research arm of Caterpillar is actually in Champaign now. For several banks, they have their data and research and coding offices are in Champaign, not in Chicago, which is where you would think they would be. US Bank has one there and others. All right, cool. Do you guys have any questions? You've been really quiet and I know I babble, but anything? You guys thinking about jobs, thinking about what you want to be when you grow up, or no? If not, I'm going to do a problem and talk about it.
God's sake, someone talk.
I know. Fine, I'll do, oops, that's you. Yep, that's me. All right, so let me start the story here. So Dr. Kim, who's she's the chair of the stat department. I'm also happen to be married to her, but that's a different story. She gives a survey out in her Stat 190 class, and it's very cool pedagogy. She gives a survey out on the first day of class, and then she uses that data in all of her examples. So yay for her, right? That's neat. Over time, she's now done this for 10 or 15 years, so she has a ton of this data that's just sitting there. And so I asked to use some of it in some of my other classes. And one of the questions that I wanted to see is, right, can we tell how tall you are from your, no, the other way. Can I predict your gender from how tall you are? Now, certainly you are unsurprised if I say, given the binary world that we traditionally live in, men are taller than women, right? And we know there's complications to that. You certainly have met tall women and short men, and all of the non-binary folks have been removed from this data set, which is maybe no fun. And then one person who said other because they didn't want to tell us their gender is left in the data set. Okay, so what we did is we made a simple chart and we just said, hey, all the females are on the top row, all the males are in the second row, the one other is in the third row, right? 60 inches is 5 feet tall, so we converted it all to inches because that makes math easy to do. And what you would see is if we look here at 5'8", there are 23 women who are 5'8" and 10 men. And that's, you know, not particularly interesting. Okay, so I made those yellow because that's where the interesting line is, right? And if you look to the left of that, I say here that most respondents were female, but actually more than that, you can see at every height, there are more women than men at every height to the left of the yellow box. In stats terms, we could say it stochastically dominates, which is a fun phrase to say. You can use that for fun. And to the right of that, taller heights, men stochastically dominate women. So again, it's not that all men are taller than women. And it's not that all men are taller than a certain height or all women are shorter than a certain height, but looks like something's going on there. And again, you're probably not very impressed with my mathematical prowess that I have successfully convinced you that on average, men are taller than women. Okay, so we can take this to a model and just say in a very simple way, we're going to predict that if anybody is taller than the yellow, we're going to predict that they're male. Okay, and again, that's not a perfect model. It's going to be wrong sometimes. And anyone shorter than the yellow, we're going to predict them to be female. This is called a naive Bayes model. Naive because it's super simple, right? I haven't done, you are still not impressed with my ability to do mathematics. Right? None of those prerequisite courses I was talking about are necessary to say that 18 is bigger than 5. Okay, and then we can go and see, well, as a model, how does this do? Well, if we take the yellow numbers and because we have to make a decision about them, because right, we want this to be something that a machine does. We don't want to have a human involved. So if we say that, let's assume 68 inches is assumed to be male, we get 80% accuracy, which is pretty good. But if we assume that this is red and this is green, we get 83% accuracy. So by making that decision, we've improved our accuracy by 3 percentage points, which is not, too shabby. Right? And of course, if we move in any other direction, right? Again, you don't need to do fancy math to say it's going to get worse, right? That's going to be the best model we have. Okay, you know who does this? Netflix. This is how the Netflix model works. It takes very simple things about you, your age, what shows you've watched before, and it creates a naive Bayes model. What makes it sort of impressive is that it does this for every single variable, for every single cut point, to try to make the best prediction that it can for what movie you'd like to watch, or what TV show you'd like to watch next. Yep.
Does it take into account specifically with Netflix, if because normally I feel like a family has one account, but then they have the different accounts in it.
It does the sub account separately. Yeah. Right. I can't give you exact answers because of course they don't tell us what their problem is. But in 2014, they posted all of their data from 2013 and said, if you can give us a better model than we have, we'll give you $1 million. And they paid 3 people $1 million. And presumably they took their advice and improved on it. Okay, so this simple one is called naive Bayes. If we do this over multiple variables, we make a tree. So each split point, so here we're saying height 68 inches predicts male, predicts female. Then at each node underneath that, we predict and we predict. That's called a classification tree. And that's a little bit fancier technique. Did it use any more math than what I just showed you? Nope. In fact, the Netflix mathematics happens on your Roku, or it happens on your phone. It's not happening at the server. It's happening in the app. That's how small and fast it is. Right? So if the data is giving you, if it's freezing, it's not something happening in Netflix. It's because your phone is slower, the internet connection is slower, whatever, but it's happening locally. We can take that one step further and say, what if we make a tree, but instead of using every variable, what if we randomly select some of the variables? So at each node of the tree, we're going to randomly pick some variables, pick the one that splits best, and go from there. That sounds kind of weird because you're like, why wouldn't you just pick the best, right? Height looks pretty good here as a divider between male and female. The other one that does is shoe size. You're unsurprised to learn from her survey, right? How much fruit you have doesn't predict gender very well at all. How much fruit you eat, how many hours of sleep you get a night, how many credits you take a semester. That doesn't predict gender very well at all. So why would you randomly pick some variables? And the reason is variation. So you get variance from making these trees that are different. Further, we can do bootstrapping because the set of all the things in Netflix is really big. So we pick a subset of all the things in Netflix. We pick random variables, a subset of variables. So we call it doubly random. It's random twice. That's how random it is. And we make a tree based off of those random decisions. By doing that bootstrapping, that is doing that random subsetting, we've sped the algorithm up by a factor of 1,000. And you would say, cool, now we can be done 1,000 times faster. But no, what we can do instead is make 1,000 different random trees. So each tree uses a different random subset of data, rows, and a different random subset of variables. Then, when it's done, it uses voting to say, oh, I made 1,000 trees, and 520 of them, it thinks you'll like Tiger King. And in these other ones, it thinks you like something else. And then it just gives you the ones that win in the model. And so that's how it gives you multiple recommendations. But more than that, that's how it learns. Right? And again, I didn't do no math. All right, I took all those classes. I was a math major. I took advanced calc and algebraic structures. I didn't need that to say that 18 is bigger than 5 and 20 is bigger than 11. And neither does the random forest inside of Netflix. That's also how Amazon works. Again, it's a slightly different algorithm. That's how the thing at Hy-Vee works. It prints out coupons. Random forests are this magical technique right now. They're being used in most predictive analytics that are simple and fast. They lose about 6 to 7% of accuracy, but run about 200 times faster than any other model at scale. That's why it can run on your phone. That's why Amazon can tell you, you might like this other book or this other product. That's also why if you hit refresh, it'll give you different suggestions because every time it's running this model again. So this question of give up accuracy for speed sounds pretty good. Okay, this is data science. This is what we talk about in Stat 220 and Stat 420. You can imagine if you've had matrix algebra, this gets a lot easier to do because things that take a bunch of time to calculate, you can just go and then you're done. And that works pretty well. All right, I'm right at time. Do you have any other questions? Anything else you want to talk about? How awesome statistics is? How do you poll Florida? None of us know. That's what everybody in my chat room is talking about today is will we ever figure out how to survey Florida in a way that gives you an accurate answer? And again, that's a mix of a mathematical question about sampling and a psychology question of do people in Florida lie? Do they change their mind? We don't know, right? We don't know what we don't know. And so that question of how those models work is something that's going to make us all stay up late at night thinking about.
Although someone will figure it out and make $1 million.
Whoever figures it out will make $1 million. Well, and it's funny because it really does seem like lying is our best guess right now, that people lie to pollsters, and especially in Florida, which that's right. And again, no amount of fancy math is going to save us from people who just lie on surveys. So. All right, cool. Well, that's all I have to talk about. If you have any questions, I'm Scott Alberts. I live upstairs. Alberts is my email. I'd be happy to talk to you.
He's very accessible.
I'm here all the time.
All the time.
I'm here. I'm one of the few people who work on campus every day. Like it's my job. Everybody else, right? Everybody else works from home, and that's cool too. And it is hanging out with you. It's what I want to do. So, all right. See you guys.
Thanks, Scott.
Yep. Yay.
Where's the end?